doing is just reviewing how to name acids and bases. We've done this earlier in the year, so now it's going to be a review of how to name these. So we're also going to be talking later on in the unit about pH, about how to do calculation with pH, and I'm sure a lot of you have heard about pH. And so we're going to talk about where did this scale come from, what does it mean, what does it reference, and so it's really all talking about acids and bases. So these notes are tying into chapter 20 and chapter 21.1 is what we're looking at. Acids and bases play a central role in the chemistry that affects our daily lives. Our bodies need acids and bases in order to function properly. So for example, human blood is at a pH of about 7.4, and your body tries to maintain that particular pH, and if it doesn't, you could what? You could die, okay? And so the kidneys especially work to do that, and the lungs will work to try to maintain that. A slight deviation may cause serious illness or death. Acids and bases are also important in manufacturing. Sulfuric acid, for example, is used if they're making fertilizers, steel, polymers, or a whole bunch of different things like plastics. It's used in all of those. Acid rain negatively affects surface waters and aquatic animals, forests, automotive coatings, materials, visibility, and human health. We'll also do some reading about acid rain and how acid rain affects all of us as well. Think about other acids and bases that play a role in your everyday life. Like citrus fruits. Anybody know what kind of acid? Well, we call it something that sounds like citrus. We call it citric acid. Perfect. They have citric acid. And so there's the formula for citric acid right there. Vitamin C, it starts with an A. Anybody know what that's called?
Acetate.
It's not. It's actually called ascorbic acid. Ascorbic. A-S-C-O-R-B-I-C. Ascorbic acid, and there's a formula for that. The pH of lemon juice is at about 2.2. We're going to talk about the pH scale in just a little bit too. If you have a really low pH, the lower the pH is, the more acidic it is. At a pH of 7, we call that what? Neutral. And then at a higher pH, we call those basic, or we call those bases. And so we'll be talking more about that as well. But lemons are about 2.2. The pH of tomatoes are about 4.1, and sodas are about 3. What type of acids are in sodas? Anybody know? There are 2 major acids that are in soda.
Aspartame.
One is carbonic acid. Perfect. One is carbonic acid. And the other one, if you were to look on here, it'll say it starts with a pH.
Phosphoric acid.
Very good. The other kind is phosphoric acid. Now, the carbonic acid, it's just, they say carbonated water, okay? But when it's carbonated, then that's carbonic acid that's in there. T, this is a hard one. It starts with the letter T, and it's the beginning of a color that starts with the T. And it's kind of the color of tea that starts with the T. Teal is not exactly the color of tea usually, but we call it tannic. It's called tannic acid. It's called tannic acid. Okay, and vinegar we used at the beginning of the year. This one does start with an A. Some of you said it earlier. Acetic acid. Now, this one we can write the name for, okay, because what we're going to review naming, but the X changed to 8. And so if this were acetate, we would write H plus because it's an acid, so it always starts with an H plus. And then acetate, I don't know if you guys remember this, it's C2, anybody remember?
H2O2.
O2. And it has a -1 charge, so then you would crisscross and get a plus and a minus, okay? Electrolyte aqueous sulfuric acid solution, that's in car batteries. So they have sulfuric acid in batteries, like the car batteries or the jet ski batteries and the boat batteries and stuff like that. Chlorine to clean a pool. This is actually called, anybody know it starts with an M? On a container, it doesn't usually say what it actually is. It's called muriatic acid, but really all it is the same acid that's in your stomach. Anybody know what that is? HCl. Hydrochloric acid. Nice. It's HCl. Very good. Okay. Now those are all acids. Okay, those are all different acids. Now let's talk about bases. Sometimes bases Typically, bases will end in OH, in hydroxide, but not always, okay? Because there are multiple definitions of acids and bases, what we end up learning is called Arrhenius' definition. And it basically just says that acids release hydrogen ions when they're in solutions, and bases release hydroxide ions. And that's the definition that we're going to end up using. But there are other definitions. The first one is mortar. What is mortar used for? To lay something.
Bricks.
Yeah, laying bricks. Perfect. It's what they use to lay bricks. This actually has calcium hydroxide in it, CaOH2, calcium hydroxide. Antacid tablets, like an Alka-Seltzer right here, this has, the beginning of it is the same as salt, which is Na, perfect, so sodium or Na. The second part is an ion that does float around in our blood, and it starts with hydrogen or bi something. Anybody want to take a guess? Bicarbonate, awesome. It's HCO3 is hydrogen carbonate or bicarbonate. Household cleaning agents like ammonia, for example. Now, ammonia is what they call the store-bought stuff, but it's really not ammonia because in chemistry, do you remember what the formula is for ammonia? NH3. This is not NH3. This is actually NH4OH, which would be called what? Do you remember what NH4 is? Ammonium. And what is OH? Hydroxide. This would be called ammonium hydroxide. Very good. Another one that's a base that's a cleaning agent is bleach. Bleach is also basic. In bleach, this doesn't look like a base because you would think they end in hydroxide typically. This one doesn't. It's actually sodium, Na. And then, anybody remember what hypochlorite is?
CLO.
CLO. Nice, CLO. Awesome, that's hypochlorite. So it's Na plus and CLO minus. Now, they tell you that you never, ever, ever, ever mix ammonia and bleach with each other, okay? And the reason why is there's a particular gas that will come off that can kill you. Anybody know what kind of gas it is? Chlorine. It's the chlorine gas that can kill you in there. It ends up emitting chlorine gas, and so they say always keep those two separated, okay? Acids and bases react together to form, I call them two people that walk into the local deli to go get some like matzo ball soup. Their names are Walter and Saul. Walter and Saul.
Like Sal?
Yeah. Which, anybody want to guess why I call them Walter and Saul?
Water
and salt. Perfect. It's actually water and salt. Okay? So if you remember the two guys walking in together, then that's going to help you. Whenever you have an acid and base, this forms water, which is a neutral solution, and then salt. Okay? And it doesn't have to be NaCl. It can be calcium chloride. It could be magnesium fluoride. Typically, they'll call a salt something that usually that ends in a halogen, but it's not necessary. Okay, I don't know if you remember this from the beginning of the year when we were doing safety. We said, do as you oughta, add the acid to the water. Awesome. Okay, so do as you oughta, add the acid to the water. All right, and when you're working in the lab to avoid injuries, that's when you would do that. Names and formulas. Okay, so just to make sure, and I know this is really bad, but it's not the best little rap thing. But we're going to say this together just one time, okay? And so I want to make sure that you remember that acids start with a hydrogen ion, and by definition, by Arrhenius' definition, acids release H plus into solution, and bases release OH minus, okay? So what we're going to say is H to the acid, OH to the base. Always keep your goggles on, safety for the face. One time, that's all I ask. Okay, ready? Here we go. H to the acid, OH to the base. Always keep your goggles on, safety for the face. Nice, good job, okay. So acids are compounds that produce hydrogen ions when they're dissolved in water, and usually they're seen as H plus, X minus. H plus is simply your hydrogen ion. That's all that's representing is the hydrogen ion. An X minus can be really any anion or any negatively charged ion. So we're just going to say it's an ion except hydroxide, okay? So not including OH minus. And the reason why is water is a neutral solution for a reason. Water's formula we've known as H2O, right? But really, water is OH. And so what we can see here is by the definition, by Arrhenius's definition, water is actually half what and half what? Half acid and half base. So water is actually half acid, half base, which is why water's pH is perfectly what? Neutral. If you're at 25 degrees Celsius and you have pure water, then we say that water's pH would be exactly 7. Okay. So let's review naming real quick. What we did was we said we would use Hyde, H-Y-I-D-E, tight us in the 8-ic. And you can use different ways to try to remember how to name them. The idea was that there's no polyatomic ion, and let's kind of take a look at our little polyatomic ion sheet here. So if there's no polyatomic ion or cyanide, okay, those end in "ide." So those are going to be the Hyde ones. You're going to do that as hydroic acid, okay? If the polyatomic ion ends in "ite," you're going to change that to "us" acid, and if your polyatomic ion ends in "ate," we're going to change it to "ic" acid, okay? Or the other way around, if you're given the name, then you just work backwards with that, okay? So we're going to take a look and try to reference our polyatomic ions too. So have this little sheet out so that you can reference it if you need to, just to remind yourself of these, what these ions are. Okay, so let's start with H2S, okay? Is there a polyatomic ion in there?
No.
No. So if there's no polyatomic ion, we're going to start this with what? Hydro. Good, it's going to start with hydro, okay? And the S, remember, if there's an R in the name, go all the way to the R in the actual element name. So this is going to be hydro sulfuric acid. Awesome. Hydro sulfuric acid. Perfect. Let's try the next one. This does have a polyatomic ion. What is that? SO3. Look at your chart if you need to. Sulfite. Perfect. That's sulfite. So if it's ite, what do you change ite to? Us. O-U-S. But go to the R in the name again. So it's not sulfus, it's sulfurous. Perfect. Sulfurous acid. Very good. Next one. So then what's SO4?
Sulfate.
Sulfate. So this is sulfuric. Perfect. Acid. And so we can see the difference. This is not called hydro. The only one that's called hydro is the very first one, even though they all have hydrogens in them. Okay? Because most people want to just throw a hydro in there because they all start with hydrogen. So the only one that starts with hydro is if it has no polyatomic ion. So now let's come to the opposite side and work these out. Well, these are all acids, so guess what they all start with? H plus. So we're going to do H, 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 and H. And so now this first one, if it starts with hydro, that means that there's no what? Polyatomic ion. Perfect. So what do you think chlor is then? Chlorine. And so Cl. And we know now that chlorine has a -1 charge. So it's just going to be HCl. And a lot of you would have known hydrochloric acid was HCl. The next one says hypochlorous acid. So hypo, not hydro. That means that I'm just going to change my ending from us. What does us change to? It's Hyde. Ite us. So this is going to change to an ite. So the question is, what is hypochlorite? Well, let's take a look on our chart and see if we can find hypochlorite. What is it?
ClO.
ClO with the -1 charge. Perfect. So now let's write down that this is ClO with the -1. So it's just HClO. You can write it without the charges after if you want. So HCl, and then this would be HClO. Okay, so then what's chlorous acid? Well, again, us just changes to ite. So what's chlorite?
ClO2.
ClO2. Perfect. With a negative charge again. Chloric. What would that change to? It changes to 8. So what's chlorate?
ClO3.
ClO3. And the last one is perchloric acid. Well, again, we're just going to change the ending to 8, which makes it perchlorate. And what's perchlorate?
ClO4.
ClO4. Okay, and our charges are all plus and minus, and so those end up canceling out. Okay. A base is a compound that gives off hydroxides when it dissolves in water. So we said that before. These are named the same as ionic compounds. All you're going to do is you're going to name whatever the cation is. So name your cation, and then it ends in hydroxide. Okay, so you're going to name the cation, and then your OH is just going to be hydroxide. Okay. So let's try some of these. Some of them are acids and some of them are bases. Okay, so let's start off with this. So in the back, we've got HF. no polyatomic ion, which means it starts with hydro, and keep going. Hydro what? Hydrofluoric. Perfect. And because it starts with an H, we're going to call it acid. Very nice. Awesome. Next one. Oh, let's go over to the right. Sorry, let's come to B. So K and then OH. So we're gonna separate that. K is potassium. Very good. And OH is hydroxide. Very nice. Pretty easy. So the bases are a lot easier. Okay, next person. So we've got NO3. Which NO3, everybody, what is that? Nitrate. So if it's nitrate, what does the 8 change to?
Ick.
Okay, so what do you think this one would be?
Nitric acid.
Very nice. Nitric acid. Awesome. Okay, next person. So we've got SO4. So everybody, what is SO4 again? Sulfate. So that's going to change to? Ick. Perfect. So what would you call it? But go to the R in the name. So that would be? Sulfuric acid. Awesome. Very nice. Sulfuric acid. Okay, next. So now we've got Ca and OH.
So calcium
There you go.
hydroxide.
Awesome. Calcium hydroxide. If you remember Roman numerals, we don't need Roman numerals unless the metal has a variable charge and calcium doesn't. So that would not need any Roman numeral. Like you can see here, it says iron 2 hydroxide with the Roman numeral. Okay, and then the last one in this section, so we've got PO3. Everybody, what's PO3? Phosphite. So what would that be?
Phosphorus.
Nice. Phosphorous acid. Because the element is just a US. All right, and then let's try going back the other way now. Okay, so we've got chromic acid. So everybody remember, what is chrome? What does ick change to? Ick changes back to A. Okay, if it's an acid, so start us off, it needs to start with what element
H
first?
plus.
H plus, very good. And then do you know what chromate is?
CrO4 -2.
Perfect. CrO4 -2. What do you do when they're not the same? Crisscross. Perfect. We need to crisscross the charge down there. Remember, it's the absolute value, so we get H2CrO4. Let's come over to the other side. So now I've got hydroiodic acid. So because it's an acid, it starts with H plus. And then what do you think this iode is going for?
Iodine.
Iodine. And iodine's charge is just a -1, so that's just high. That's what that makes. Okay. Next one, iron 2 hydroxide. Okay, so iron, in this case, what is this 2 referencing? So next person, what's this Roman numeral 2 referencing? What does that mean?
Oh, me?
Yep.
It's like the charge.
Perfect. So that's iron's charge is a +2. And then hydroxide, next person, hydroxide is what? OH. And so we're going to put OH minus. And next person, now what do we do?
Crisscross.
Crisscross. Awesome. The 2 is going to come right down there, and we get FeOH2. Perfect. Next person. Okay. Lithium hydroxide. So lithium is just what?
Li, right?
Yep. Li with a plus charge. Perfect. Okay, and hydroxide is?
OH.
Perfect. OH minus. And then it's a plus and a minus, so that cancels out. Okay, we've got nitrous. So us changes to what, everybody, before I ask the next person? Ice. Very good. Because this is an acid, so next person? H plus. And then what would nitrite be, next person? NO2 minus. Awesome. And so those cancel out also. And last one is hydrosulfuric acid. Again, since it's an acid, it starts with H plus. Okay, and then since it starts with hydro, that means no polyatomic ion. Sulfur. Very good. And sulfur's charge, everybody, is what? -2. So when you crisscross this, you're going to get H2S. Okay? All right, and so what's going to happen now is you're going to go and you're going to start working on the naming of the acids and the bases. You're going to skip this for now, and then we're